Today we're looking at Module 3, Lesson 3, where we're starting to actually add fractions with unlike units or unlike denominators. And we are going to do that by turning our unlike denominators into common denominators. So let's look. So it says draw a rectangular fraction model to find the sum. Remember, meaning that sum is the answer to a division, or sum is the answer to an addition problem. And they always want us to simplify our answer if possible. So if we look at A, and we have 1/4 plus 1/3. We cannot just add these together because our denominators are different. We have a 4 and we have a 3, which means that our fractions are different sized. I can't add 1/4 of a pizza with 1/3 of a pizza and say I have a certain amount of pizza. I need them to be the same size fraction so I can add them together and get an actual answer. So we're going to learn the strategy of finding common denominators by using a rectangular fraction model. And you do that by drawing two squares. Each of these squares represents one of these numbers. So I'm going to draw 1/4 in one square. So here's my 1/4 in that square. And then I'm going to draw 1/3 in the other. And I'm going to do the other one horizontally. That third looks a little big, but we're going to go with it. Now, you can see that these are different sizes. So I can't just combine them. I need them to have the same size. I need them to be the same denominator. So what I'm going to do is I'm going to take this 1/4 and I'm going to split it into thirds. And the reason I'm splitting it into thirds is because I'm taking this 3 from over here and applying it to the 1/4. And then I'm going to take this 1/3 and split it into fourths. And again, same thing. I'm basically overlapping my horizontal and my vertical lines. Now I've created fractions with a denominator of 12. Because if I counted them, I'd have 12 squares. And if I look at this 1/4, I no longer have 1 out of 4 shaded in. I have 3 out of 12. And if I look at this 1/3, I no longer have 1/3. I have 4 out of 12. So I've created a new problem, and I had 1/4 plus 1/3, and I've rewritten it as 3/12 plus 4/12. I found equivalent fractions. 1/4 and 3/12 are equivalent fractions, and 1/3 and 4/12 are equivalent fractions. And now that I have the fractions that have the same denominator of 12, I can add them together. So I can do 3/12 plus 4/12 equals 7/12. Now I can't simplify this, and I know I can't simplify this because if I think about the factors of 7, I only have 7 and 1. And neither 7 nor 1 really go into 12. 1 does, but dividing 7 and 12 by 1 isn't going to change anything. So my final answer is going to be 7/12 to add 1/4 plus 3/4. Let's look at B. Now I've got 1/4 plus 1/5. I'm going to do that same thing. I'm just going to write it over here. So I'm going to do 1/4, and I'm going to do 1/5. So I have 1/5 over here, and I have 1/4 over here. And now I'm going to make a common denominator, the same size piece, by splitting this 1/4 into fifths, and splitting this 1/5 into fourths. Now I've changed this 1/4 into 1, 2, 3, 4, 5 20ths, and I've changed this 1/5 into 1, 2, 3, 4 20ths. Because what I did is I took this and I times it by 5 times 5, and I times this by 4 to get the common denominator of 20 and 20. So now I have 5 20ths plus 4/20, and I'm going to get 9/20 as my answer here. So 1/4 plus 1/5 equals 9/20. Again, I'm going to check for simplification. I don't think I can because factors of 9 are 3, 9, and 1, and neither 3 nor 9 evenly go into 20, so that means 9/20 is my final answer here. Let's look at F. F is the same thing, but now in our numerator, you'll notice we just have numbers bigger than 1. So these are non-unit fractions, and we're going to treat them the same way. So we're using our rectangular fraction models, and I'm going to do 3/5 in this first one. So 1, 2, 3, 4, 5, and I'm going to shade in 3. So this is 3/5. And then in my second one, I'm going to go horizontally, and I'm going to make sevenths. 1, 2, 3, 4, 5, 6. And I'm going to shade in 3. So I have 3/7. So fifths and sevenths are different size pieces. I need to make them the same size. So I'm going to take my fifths and split them into sevenths. 1, 2, 3, 4, 5, 6. So basically I'm timesing by 7, which gives me 21/35. And I can double check that by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 out of 35. Good. And then for my 3/7, I'm going to split it into fifths. 1, 2, 3, 4. So I'm basically timesing by 5, and I'm going to get 15/35 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I get 15/35. So my new equation has become 21/35 plus 15/35. So in this original equation, I had numerators that were both the same. They were both equal to 3. But now that I've turned them into different equivalent fractions, they've turned to 21 and 15. So when I add this together, the 35 will stay the same because whenever we add fractions together, my fraction size stays the same, so it stays 35. And 21 plus 15 is going to be 36. Now, 36/35 can be simplified because this is a fraction greater than 1. And I know I can take 1 whole 35/35 out of here. So I get 1 whole, and that will leave me with 1/35 left over. So my final answer is 1 and 1/35. Let's practice it with a word problem. Cynthia completed 2/3 of the items on her to-do list in the morning and finished 1/8 of the items during her lunch break. What fraction of her to-do list is finished by the end of her lunch break? Okay, so she completed 2/3 of it in the morning and 1/8 during her lunch break. And they want to know what she finished by the end of her lunch break. So what has she finished so far? So she did 2/3 in the morning plus 1/8 during her lunch. And they want to know what that equals. So I'm doing 2/3 plus 1/8. So I cannot add 3 and 8 because they're different size denominators. So let's make them equivalent fractions. So we'll start with the thirds. So it's 2/3. And then we'll do the eighths. 2, 3, 4, 5. Oops. I'll just make the square a little bigger. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And it's 1/8. So now let's make them equivalent. I'm going to take my 2/3 and I'm going to divide it into 8 pieces. 1, 3, 4, 5, 6, 7. Good. So I'm basically timesing by 8, finding an equivalent fraction of 16/24. And then my eighths, I'm going to split into thirds. And I times it by 3 if I'm splitting into thirds. And so I'm getting 3/24. So now, instead of adding 2/3 plus 1/8, I'm going to add 16/24 plus 3/24. And that gives me 19/24. Now I cannot simplify because 19 is prime. 19 cannot go into 24. So I get 19/24 of her to-do list is what she finished. Now the extension says how much does she still have left to do after lunch. And so if we think about this as her whole list, and we know she finished 19/24 is what she finished. They want to know what's left. So I can basically do 1 minus 19/24 to figure out what's left, because I have a whole minus 19/24. So I need to know how many to add to 19/24 to equal 1, which is really 24/24 minus 19/24. So it looks like she has 5/24 of her list left. So that's the extension part. But basically we were able to take two fractions with different denominators, turn them into equivalent fractions of the same denominator, and then we're able to add them together. So that's the main strategy that we use when we're adding fractions with unlike units, is we turn them into equivalent fractions and with the same denominator, and then we're able to add them together. And we use that rectangular fraction model today to make those equivalent fractions.